Welcome back. In this video, we'll explore one critically important aspect of understanding how such a relatively tiny number of pairwise tests can be so powerful. As we've already seen in two prior videos, the total possible number of permutations in a system under test grows exponentially. Using this easy-to-understand system under test, we jumped into Hexawise and saw that as the number of parameters in our system under test grew from 2 parameters up to 9 parameters, the number of tests tripled and tripled and tripled again, and quickly reached almost 20,000 possible tests that could be executed. And we saw an extremely curious result, that the number of tests needed to execute all possible pairs, or pairwise coverage, grew just a tiny amount. It's very curious that the total number of possible permutations exploded from 9 to almost 20,000, but the number of pairwise tests for the same system under test that was growing from 2 parameters to 9 parameters only grew from 9 to 17 pairwise tests required. So how is it that our examinations revealed that the number of total possible tests was growing at a rate that is more than 1,000 times faster than the number of pairwise tests required? Something very important is going on here, and you don't need to understand the exact mathematical details, but you should definitely understand the general concept. It's important to remember that pairwise tests, by definition, do not attempt to cover all possible permutations of a system under test. Instead, two-way tests, known as pairwise or all pairs tests, focus on covering all simple interactions of the system that cover all possible pairs within the system under test. So we'll examine the implications of what that means with this video. Let's take the focus away from the exploding number of total possible permutations and put our attention instead on what is happening to the number of pairs that need to be tested in our system under test, as it again goes from 2 parameters to 3 to 4 to 5 up to 9. Fortunately, using the matrix chart in Hexawise makes our analysis very straightforward. With 2 parameters, applicant credit rating and applicant income, we'd be able to eyeball this and quickly determine we need to test for 9 pairs. There are 9 possible pairs. There are 9 tests. We need to execute every test in order to test each of the pairs. We see in the matrix chart in Hexawise those same 9 pairs laid out here. When we have 2 parameters and 3 values per parameter, we need to test for 9 pairs. Increasing the scope to 3 parameters increases the pairs in scope to 27. 4 parameters increases it to 54 pairs. 5 parameters gets us to 90 pairs. 6 parameters, 135 pairs. And you'll notice here that we are not tripling and tripling and tripling again. Total number of possible permutations, yes, we would be tripling at this point. We'd be getting into the thousands. Here, when we add a 7th parameter into the plan, we're increasing a modest amount. It's a significant, but it's a modest amount. 8th parameter gets us to 252 pairs in scope that need to be tested. And with our full system under test of 9 parameters, we only have 324 pairs of values that need to be tested together. So when we take our focus away from the total number of possible permutations and pay attention instead to how many pairs need to be covered in our system as it grew, now it probably seems less unbelievable that a relatively modest number of pairwise tests can achieve our coverage objective of testing every possible pair. When you realize that there are only 324 pairs in this system under test, it becomes pretty clear that we would not require thousands and thousands and thousands of tests to cover each of these 324 pairs. But something else interesting is going on here too. How does Pairwise test for all 324 pairs in just 17 tests? If you do some quick math there, that would mean that each test, on average, is covering 19.1 pairs per test. So how does that work? We'll dig into that aspect in the next short video. Thank you.